Hello students, in previous bridge course activity video we have studied few basic concepts in the maths. Today we are going to discuss about the concepts given from the 9th August to 15th August, which is given in bridge course activity program. Then see here the few concept which is related with maths 1 as well as maths 2 we will discuss here in this lecture. Then first of all of you have studied about that algebraic expressions. Algebraic expressions means, see here, these are the expressions or terms in which there is alphabets are also used with numericals. For example, see here, 5x is an algebraic expression which is known as monomial. Monomial, that is, mono means one, that which contains only one term, and one term it is composed of, that is, one coefficient, variable. The alphabets in small letters which is used here is known as variables, and the degree of variable and degree of variables all together form one term. And when that algebraic expression contains only one term, then it is a monomial. As well as there are examples of algebraic expressions, that is, see here, 5x minus 7y. It is also algebraic expression which is known as binomials. Binomials which contains two terms. There are two terms, that is, 5x is one of the term while minus 7y is another term. In first term there is 5 is coefficient, x is variable, and 1 is degree, as well as in the second term minus 7 is coefficient, y is variable, and 1 is the degree of that variable. Then there are few more examples I am going to discuss with you about that algebraic expressions, that is, x plus 2y, 2x square plus 3xy plus 7. That is also one of the algebraic expression. Then see here, in the algebraic expressions, that 7 is one of the term which is known as constant term. That is known as constant term. And that constant term, here 7 is a constant term which is written like this, 7x raised to 0. X raised to 0 means 1, that means, that is, 6 raised to 0 means 7, which is known as constant term in the polynomial or algebraic expression. Those are the few examples of algebraic expression, and we have already studied in previous lecture also about that algebraic expressions. Then see here, when those algebraic expressions contains many terms, then it is known as polynomials. Generally polynomials, it may be monomial, binomial or trinomial. Together it is called as polynomials. And that polynomial in which many terms are there, between two terms minus or plus sign should be there. Then that are the few examples of polynomials or algebraic expressions. Then one more concept, that is equations. One of the example of it, that is 3x square minus 5 is equals to 0. That is the example of equation. That means here there are two sides, that is left hand side and right hand side, and there is always equality between LHS and RHS. That is known as equations. There are few more examples, that is 2x minus 5 is equals to 7 is one of the example of equation, as well as minus 5x square plus 7x minus 9 is equals to 5 is one of the example of equation. Then we have already seen about those equations, that is there are linear equations in one variable, as well as linear equations in two variables. All of you studied about that in previous lecture. For example, linear equation, the equation of which degree is 1, that is here 2x minus 5 is equals to 7 is the example of linear equations in one variable, because here degree of this equation is 1 and here only one variable is used, that is x. But see here, then 2x plus 5y is equals to 7 is one of the example of linear equation in two variables, because here degree of those variables is 1, therefore it is a linear equation. But here two different variables are used, that is x and y, therefore it is a linear equation in two variables. All of you have studied about that. Then we will solve few equations. That means solving equation means to get the solution or root of that equation which can satisfy the both sides, that is LHS becomes equals to the RHS. For example, see here 5x plus 2 is equals to 27. Then see here, if here x is equals to, putting the value of x is equals to 5, then we have to find out whether this value of x will satisfy that equation or not. Then putting the value of x is equals to 5 here, therefore 5 into 5 plus 2 is equals to 27. Then 5 into 5, that is 25 plus 2 is equals to 27. Here 27 is equals to 27. Here LHS is equals to RHS. Therefore here the value of x, that is 5, which can satisfy that equation. Therefore here 5 is x is equals to 5 is a root of, or it is a solution of above equation, Then one more example, that is see here x minus 4 is equals to 3. In this equation we have to determine whether the x is equals to minus 1 is the root of given equation or not. Means whether minus 1 is a root of given equation or not. We have to determine, we have to put the value of x is equals to minus 1. Therefore minus 1 minus 4 is equals to 3. Minus 1 minus 4 minus 5 is equals to 3. Here minus 5 is not equals to 3. Therefore here x minus 4 is not equals to 3 for x is equals to minus 1. Therefore, here LHS is not equals to RHS for the value x is equals to -1. Therefore, -1 is not a root of, it is not a root of above equation. Similarly, we can solve few more equations given here. That is, for example, 5a minus 10 is equals to 0. Therefore, see here, to solve this equation means to find out the value of a, that is variable. Therefore, see here, 5a minus 10, then minus 10 is taken at right hand side. 5a is equals to 0 plus 10. Therefore, 5a is equals to 10. Therefore, here a is equals to 10 upon 5. Therefore, here we get a is equals to 2. Then a is equals to 2. 2 is a solution or root of above equation. Then like that we can solve few more equations. That means solving equation means to find out the roots of those equation, and finding out the roots of that equation means to find out the value of variable given in the equation which can satisfy that equation. Then one more example, that is 2 into x minus 3 is equals to 3 upon 5 in bracket x plus 4. Then how to solve this? There are two different methods. That is, one of the method I have discussed with you while solving this equation, as well as there is one more method to solve this type of equation. That is, see here, at right hand side 3 upon 5, that 5 is at denominator. Therefore, we have to multiply this by 5, and as we multiplied this side by 5, therefore we should have to multiply by 5 to left hand side. That means multiplying both side by 5. Therefore, here 2 into x minus 3 into 5 is equals to 3 into 5, 3 upon 5 into 5 in bracket x plus 4. Therefore, here we get 2 into 5, that is 10 into x minus 3 is equals to, here 5 get cancelled. Therefore, here we get 3 into x plus 4. Then we have to multiply by 10 to this bracket. Therefore, we get 10x minus 30 is equals to, here 3x plus 12. Then see here, at left hand side 10x is there, and at right hand side 3x is there. Therefore, we have to subtract 3x from both side. Therefore, 10x minus 3x minus 30 is equals to 3x minus 3x plus 12. Then see here, 3x minus 3x get cancelled. Here 10x minus 3x, that is 7x minus 30 is equals to 12. Then see here, we have to adding 30 on both side. Therefore, 7x minus 30 plus 30. Therefore, we get 12 plus 30. Therefore, minus 30 plus 30 get cancelled, and here 7x is equals to 12 plus 30, that is 42. Then see here, we get 7x is equals to 42. Therefore, we have to divide by 7 on both sides. Therefore, we get 7x upon 7 is equals to 42 upon 7. Therefore, we get cancelled, that 7, and here we get x is equals to, here 7 ones are 7 and 7 6 are 42. Therefore, we get here x is equals to 6, and that means x is equals to 6 is a root of that given equation. Similarly, we can solve the equation by two different ways. All of you have studied about that in previous standard, as well as there are few word examples, that is applications of linear equation in one variable, as well as application of linear equation in two variable. That means word examples on equations in one variable or equations in two variable also. That is, if Govind has some money and his mother gave 7 rupees to him, then now Govind has 10 rupees. Then write the equation for that word example or for that condition. Let us consider at first Govind has some money, that is Govind has rupees X at start. Then according to the given condition, his mother gave him rupees 7. Then that now Govind has rupees 10. Therefore, by given condition, we can write x plus 7 is equals to 10. That is the equation which is obtained from that word example. Then one more example, word example, that is Raghav is 3 times older than his younger brother, and sum of their ages is 20 years. Then see here, Raghav is 3 times older than his younger brother. That means we don't know the age of younger brother, but Raghav is thrice of the age of his younger brother. Therefore, let us consider the age of younger brother be x years. Then from given condition, Raghav is thrice older than his younger brother, and sum of those two brothers, ages of two brothers, is 20 years. Therefore, by given condition, 3x plus x is equals to 20. Then see here, Raghav is of 3x years and his brother is of x years, and sum of the ages of both two is 20. That is about the word examples. Then we will discuss about the application of equations in everyday life by solving one of the activity here. Then complete the following activity. Then in activity, see here, the condition which is given, that is here, my age is x years. Then from that we can prepare few more equations by observing the conditions. Then that is, my grandmother is 7 years older than thrice of my age. That is, for we can write the equation by considering that condition. See here, grandmother is 7 years older than thrice of my age. Then thrice of my age is 3x, and 7 years older means 7 years more, that is 3x plus 7 years, that is the here age of grandmother. Few more conditions are given. My sister is 5 years older than half of my age. Then see here, from given condition, age of sister is, that is half of my age means x upon 2 plus 5 years older, that is 5 plus 5 years here, years. Then see here, age of sister is x upon 2 plus 5 years. Then one more condition is given here, that is my brother is twice of my age. Therefore here age of brother is 2x years. Then see here, my mother is 10 years older, than twice of my age. Therefore here age of my mother is 2x plus 10 years. Here my mother's age is 10 years older than twice of my age. Therefore age of my mother is 2x plus 10 years. Then one more condition is given here. My father's age is 32 years elder than my age. Therefore, here age of my father is x plus 32 years. Then see here, few word examples of equations are given here in the. Then we will study about few basic concepts related with the geometry. Then see here, triangles. All of you have studied about the triangles and their types. See here, types of triangle which is based on the sides of triangle. Then there are three types, that is equilateral triangle, in which all three sides are congruent. See here, in triangle ABC, AB is equals to BC is equals to AC. Then second one, that is isosceles triangle, in which only two sides are congruent, that is here PQ congruent PR. And last one, that is third one, is scalene triangle, that is, it is a triangle in which all three sides are of different length, that is triangle LMN. Then that is the few different types of triangle which is based on the sides of that triangle. There are also three more types of triangle which is based on angles of triangle. Then first one, that is acute angled triangle. The name itself indicates that the triangle in which all three angles are acute. For example, 50 degree, here 70 degree and 60 degree. All three angles are acute angle. Here angle A, angle B and angle C are acute angle. Therefore it is an acute angle triangle. Then second one, that is if only one of the angle of triangle is obtuse angle. Then see here, in triangle LMN, angle M is of 120 degree. Here it is of 30 degree and it is of 30 degree. Then second one is a obtuse angled triangle in which one of the angle, that is angle M, is obtuse angle. And last, that is third type of triangle, that is triangle PQR, in which angle PQR is 90 degree. Therefore it is a right angle triangle. Then that are the different types of triangles which is based on sides of triangle as well as angles of triangle. Then we will discussing few properties which is related with the right angle triangle. First of all of you have studied about that sum of all three angles of any triangle, any type of triangle is 180 degree. Is 180 degree. Then we have to discuss on the property of right angle triangle, that is Pythagoras theorem of right angle triangle. That property, Pythagoras theorem or property, is only applicable to the right angle triangle. Therefore, first of all, we have to discuss few basic things which is related with the right angle triangle. That is, see here, triangle ABC in which angle B is 90 degree. Therefore, in triangle ABC, angle ABC is of 90 degree. Therefore, here AC is a hypotenuse. AC is a hypotenuse. And side AB and side BC are the sides which makes right angle of triangle. Therefore, here one of the side, that is side AB, is known as height of that triangle, and BC, which is known as base of triangle. Then see here, BC is base while AB is height and AC is hypotenuse of that triangle, and angle B is of 90 degree. Then see here, the Pythagoras theorem which is related with the right angle triangle is that hypotenuse square is equals to that height of the triangle square plus the square of base. That is the Pythagoras theorem. That is, here hypotenuse is AC, that means length of AC square is equals to length of, here height is AB, therefore here length of AB square plus here length of base, that is BC square. There are few examples which is based on that Pythagoras theorem. We will discuss about that. See here, in right angle triangle, the sides which makes 90 degree are 9 centimeter and 12 centimeter. Then find the hypotenuse. Then see here the sides which makes the right angle is AB and another side which makes the right angle, that is BC. Therefore, one of the side is 9 centimeter and other side of length 12 centimeter. Then we have to find the length of hypotenuse. Therefore, according to the Pythagoras theorem, here LAC square is equals to LAB square. See here, AB is given here, that is 12 square, plus BC is of 9 centimeter, 9 square. Therefore, here 12 square 144 plus 9 square 81. Therefore, here 4 plus 1 5, 8 plus 4 2, 12, 2, 1, carry 1, that is 225. That is the length of AC square is 225. But 225 means it is a 15 square. Therefore, taking square root on both sides, taking square root on both sides, that is length of AC is equals to 15 square, square root of 15 square, or square root of 225 is 15. Therefore, here the hypotenuse is of 15 centimeter. Using Pythagoras theorem, we can solve this type of examples from exercise. There are set of 3 numbers in which if square of biggest number is the sum of squares of remaining other 2 numbers, then that set of 3 numbers are called as Pythagoras triplet. Then what is Pythagoras triplet means? It is a set of 3 numbers in which square of biggest number is the sum of squares of remaining 2 numbers. Then those set of 3 numbers are known as Pythagorean triplet or Pythagoras triplet. Then for example, see here 3, 4 and 5. We have to determine whether that set is a Pythagorean triplet or not. Then first of all, see here, from this the biggest number is 5. Therefore, we have to get the square of that 5 is 25. And here 3 square plus 4 square. Here we get 3 square 9 plus 4 square 16. Then 9 plus 16, that is 25. That means from this calculation we can write that 5 square is equals to 3 square plus 4 square. Here therefore 3, 4 and 5, it is a Pythagoras triplet. Then see here 3, 4, 5 is a Pythagoras triplet. If we multiplied by 2 to all these numbers, then we get, see here, 3 2s are 6, 4 2s are 8 and 5 2s are 10. Then we have to determine whether that 3 numbers are Pythagorean triplet or not. Then solving this, 10 square, 6 square and 8 square. Then see here 10 square, that is 100. 6 square, that is 36, and 8 square, that is 64. Here 6 square plus 8 square, that we get 36 plus 64 is 100. That means here 10 square is equals to 6 square plus 8 square. That means here set of 6, 8 and 10 is also Pythagorean triplet. Then if we multiply by 3 to all those 3 numbers, that is 3 3s are 9, 3 4s are 12, 3 5s are 15, it is also Pythagorean triplet. As well as if it is multiplied by 5, 5 3s are 15, 5 4s are 20 and 5 5s are 25. Then those are also Pythagorean triplet. Similarly, we can get few more sets of Pythagorean triplets. Then here, that is about the few basic concepts from Maths 1 and Maths 2, which you have already studied in 8th standard, which is given in the 9th August to 15th August. And that is the last video of bridge course activity, because here at 45th day there is one more unit test is there, that is unit test 3. Then those all concepts from day 1st to day 45, those all basic concepts which is discussed in the bridge course activity, you should solve that unit test in your textbook, and you have to submit that to your subject teacher after 15th August. Then the exercise which is based on those basic concepts are also given at the last of that video. You have to solve those exercises in your textbook also. Then here bridge course activity program is completed, and it is your responsibility to solve all exercise from day 1 to day 45 in your textbook, and as well as you have to solve all 3 unit tests in your textbook and have to submit it to your subject teacher. Thank you all.